Hello guys, how are you? So today I'm gonna solve this problem step by step directions from a binary tree to another. So this question is saying step by step. So similarly we will also solve this problem with the step by step. Okay. So the question is basically, let me summarize. One binary tree is given to us. For example, this tree. Okay, and two integer values are given. One of them they are calling start value, like in this case 3 is the start value and 6 is the destination value. Okay, so then we have to find the path between these two. So if we start from 3 and if we want to reach to 6, so see here, from 3 to 1 we will come up direction, so they are calling it u. Again we have to go u, then we are going to right side of 5, right? Then this is right, then we are at 2, then we are taking a left, so this is L. So u r L, so this string should be our answer. This is what we have to do. But guys, this is one of the favorite case, okay, of example. We just cannot rely the favorite cases. Our logic might not be the handling everything if we look at the only certain favorite case. So I will take a better example, two examples, then it will make a better sense for all scenarios. Okay, so let me go through a diagram. So guys, can you see this example? Here's 3 is the our start point and 7 is the end point. Okay, destination. So if we look at the path, what would be the path here? The path would be something like this. We will start from here. So this would be going in this way. So see here, we are starting from 3, we are going up direction, right? So one u is there. Then we will go to one more u here, right? Because this is also up direction. So one more u will be there. Then we reached at 5. Then this is the right child of 5. Then one r would be there. Now we are at 6, right? Then this is the again the right child of 6. So u r r would be the answer of this diagram. Okay. Now the thing is how to approach. Okay, this is all what we have to do, but the thing is how to approach. So the approach is very simple. Number one is we should know how to find the common ancestor of any two nodes. Okay, which is quite simple. I have put the code of it. So see here, if 3 and 7, so what would be the common ancestor? It will be like 2 is ancestor of 3, but it is not the ancestor of 7, right? So 2 cannot be the common ancestor, right? Similarly, 6 is the ancestor of 7, but not the ancestor of 3, right? So 6 is also cannot be. But see, 5 is the common ancestor, right? Because 3, from 3 also we can reach to 5, and from 7 also ancestor. If we look at the ancestor list, it will also come in the ancestor list. So we should know how to find the least common ancestor. So 5 is the least common ancestor. Those 10 is also an ancestor, but it is not the least common ancestor. So first of all is we have to find the least common ancestor. So guys, basically there would be 3 steps to solve this problem. Number one is we have to find the least common ancestor of both these values, start and the destination. So once we found the least common ancestor, like 5 in this case, so we found it, first step. Second step is like find the path from the least common ancestor to both these 3 and 7, right? So from 5 we have to find the path to 3, and similarly the path to 7. Okay, so if we go to in this way, what would be the path? So path would be from 5, first we will come here, so it would be r, right? We are going to right side, then we are here, then this is also going to right side. So the path from LCA, least common ancestor, to start would be, in this case it would be RR. Okay, now after getting RR we have to find the path from LCA, least common ancestor, to the destination. So see here, this guy is also going to right side, so another R, and this is also going to right side, so R. Okay, now so RR and RR. Now listen here, this is the right side path, I mean the destination path, and this is our start point path. But you know that from start, this path is when we are coming from least common ancestor to this guy, but actually we need the reverse path. And you know, when we go to reverse way, it is always the u and u, right? So we can directly say that whatever path we have got from least common ancestor to start point, if we repeatedly put UU instead of RR, or you can say in general whatever length of this path is there, like RR in this case, so length is 2, so basically we have to put 2U. Okay, 2U plus whatever path we got for the destination, so 2U plus this RR, this will give us the answer. Okay, so in this way we can do the solution of it. Let us do it right and once. So in this example I am taking the one which is given in the question. So first of all, in step 1 what we have to find? Step 1 we have to find the LCA. So what is the LCA here? LCA here is the 5, right? LCA for 3 and 6. So start is 3, end is 6. Okay, so if we find the LCA, this is 1 and 2 is not the LCA, 5 is basically the LCA. So first of all we have to find the LCA node. So this is the node which is LCA. Now number 2, from this LCA we have to find the path to both start and destination. So let's take for start first. So we will find from here. So 5, okay, so we have to go to the right side of it. Okay, so 1 R would be there. Okay, so R. Then we have to again go to the right direction only. So this is also R. Okay, so this is our path to start 1. Okay, start 1. Okay, now we will go to path for the destination. So we will start here, we are going to right direction, correct? So we are coming to there would be 1 R would be added. So we are at 2. Now we have to go to left side of it. So this is L. So R and L. Okay, this is the destination path, right? Now what I told you in step 3 is, in step 3 whatever the length of this guy, the path which we got from the LCA to the start point, we have to get the length of it. So length is 2, that means 2 times we have to put the U directly. Okay, for the simple reason that from here we can go only to the up direction, right? So up is U. Okay, so whatever length of it, that many times. So this is U only, this is U only. Okay, so for that reason we got length of it and we put that many times U. And whatever the destination path, we have to directly append this guy. So U, U, R, L. This would be our answer, as simple as that. Okay, now I will show you my code. I will explain even how to find the LCA and how this overall works. So let me explain my code for you. So I see here, first of all I have written how to find the least common ancestor. Okay, so these are our start and end value, and this is our root. So if root is equal to null, then obviously null would be our LCA. But if root dot val equal to either start or equal to end, that means that guy should be the root, right? For example, let's say if this is like 10 and 20. Okay, let's say these are the only two things, right? 10, 20 in the root, in the array, and array in the tree, right? Let's say this is kind of 3, and this 10 and 20 is our start and end. So in this case, what would be the LCA? 10 itself would be the LCA, right? So for the same reason we are saying that if when we are keep on calling like this, if it is not, then we will go to right side. Now see here, there is a condition that this guy itself is equal to one of them. Then we will return this guy itself as a least common ancestor. So for same reason I have written this case. So see here, if any one of them is matching, that root, that node would be basically not necessarily the root only, because see, this is a recursive approach. So whenever we are calling on any node, that would be behaving as a root node for that call. So for that reason, if it is matching with any one of these values, we were returning only this guy. Otherwise, what we are doing here, we are doing the bottom up approach. So we are going to the left side and we are going to the right side. Okay. So in this case, if both of them, none of them is empty, null, means the values are on left side and right side. That means our root would be basically the least common ancestor. Otherwise, we will check if left side is not null, then that would be the least common ancestor, or else it would be the right. So this is you have to basically learn before solving this problem, that how to find the LCA of two numbers in a binary tree. Okay, so after solving this sub problem, then we will further go ahead. Then what we are doing, so we are done with the step 1 to find the least common ancestor. After doing this, what we gonna do is we have to find the path. So I have written this method which will basically give the path from any road to any target node. Okay, so what I'm doing here is I'm passing one string builder parameter and the target value, whatever it is, because this would be a common method to get the path of it. So see here, if root itself null, then we are returning the false. This is a boolean type, so we are doing two work. Boolean is the return type, but we are also modifying the path variable. Okay, so see here, if root.val equal to tgt, that means we should return the true, right? Otherwise what we will do, see here, this path dot append l means we are first checking to the left side. We can check even the right side, not a problem, but we are taking here for left side. So if we are taking any step towards left side, that means we have to in path we have to add the l, because l indicates the left side. Okay, then we are checking whether if this guy is leading to true or false. Okay, so whatever this tgt, whether we are reached the tgt or not. So see, this is again we are calling the recursive function. So if this is true, then we have to return. If this is not true, that means we have to undo this step, right? This would be the backtrack. Backtrack means undoing if something favorable is not happened. Okay, so see here, if it is true, then we are only we are directly returning. Otherwise we are here doing the backtracking, means whatever we added here, we are basically decreasing the size, so automatically this would be decreased. This l would be removed from this path variable. Okay, and then we are calling on right side. If we are not getting the desired answer in the left side, then we have to go to right side. So obviously before going to right side, we have to append the r, right? And then we are checking whether on the right side we are getting it. If we are getting, then we are returning true. Otherwise we are again making the backtrack step. So we are undoing whatever r we added here. We are basically removing the last element from this path variable so that we can do the undo. Now if we are not able to return so far in this code, that means we have to return the false. Okay, so this is our method which will give the path string or string builder, you can say. This will give us path from root to any int target. Okay, now we will use this method, the lowest common ancestor method, and this method. Okay, so we will go to now for the main method. So see here, first of all I am calculating the least common ancestor. With LC I am indicating least common ancestor. Now see here, I am just creating two path variable, start path and end path from LCA. So see here, I am taking the get path in these two values, start path and end path. See, I am calling for start value first, then I am calling for destination value first, then start path and end path would having those strings. Okay, now after getting those things, see what I am doing, I am just creating the directions variable. Now see here, first of all what I am doing, directions dot append u, and I am repeating, adding this u to the whatever length of the start path as we discussed in our diagram, right? See here, we got the start path RR, right? So two times we have to append it UU. So for the same reason I am doing there as well. So after appending the U for the length time, then I am directly appending whatever was the end path. Okay, and finally I am converting it to string and I am returning it. So let me execute the code. So I am executing the code. It is working. Let me run for all examples. Yeah, it is working. So let me submit it. So we are taking O of n here. Okay, so this is a linear time complexity, and so thank you for watching the video, and if you guys have any concern, please make a comment over there. Thank you.